Today we are going to be learning about blood, really generalities of blood and blood typing. We're going to learn about blood spatter at a later date. So the average adult has about 5 liters of blood. For those of us who are American, that's like 1.3 gallons of blood. Maybe more, maybe less than you would think. But you know, it's pretty liquid, so I think it tends to look like a lot more when it comes out. But it's not as thin as water, but it's not as thick as you might think. A healthy person, so someone with no underlying conditions, can endure anywhere from a 10 to 15% loss of blood. So about a half liter to 3/4 of a liter without serious medical difficulties, meaning that you can lose it, you can come back from it, maybe you might feel a little lightheaded, but otherwise probably be okay. Of course, there is a method of dying called exsanguination, where you are bleeding out. So ex meaning exit, sang meaning blood. So blood is exiting. So if someone dies from exsanguination, they're dying from severe blood loss. Fun fact, if you are donating blood, they usually take about 8 to 10%. So they're basically draining blood to the point where you probably get lightheaded. So if you ever donate blood, make sure you follow their directions, stay where you are, eat a cookie, drink some juice, and let your body recover. So blood is made up of a bunch of different stuff. One of them is red blood cells. They're the most abundant cells in your body, meaning that if I counted out all of the cells in your body, red blood cells would be the highest number. They're not the most voluminous, meaning, right, if I like stack them one on top of each or put them in a container or whatever, I would have probably less of red, my volume would be less, but because they're tiny, but I have a lot of them. They're made in the bone marrow, and they have hemoglobin, which carries oxygen through your body. That's why red blood cells are so important. And you know, obviously your body needs oxygen for cellular respiration. Another fun fact is that carbon monoxide bonds very readily to hemoglobin, and so that's why they call it the silent killer, because if carbon monoxide is bonding with hemoglobin, oxygen can't. And so while you don't feel like you're suffocating, you actually are. Your body is starved for oxygen, and you start to fall asleep, and ultimately people do die that way. That's why you should have a carbon monoxide detector in your home. Smokers tend to have low blood oxygen because cigarette smoke also has carbon monoxide in it. White blood cells are another cell in your blood. They're defending your body against foreign materials. So like if you get a splinter and you see like it kind of gets pussy, that would be your white blood cells. And plasma is the liquid that your cells are suspended in. It's mostly water, but it contains all kinds of stuff. But what we're going to really concern ourselves with are antibodies. So antibodies help fight off infection. Very relevant with vaccines, right? You're introducing a vaccine or a part of a virus into your body, and your body is learning how to fight it off with antibodies. And so antibodies are really important with vaccines, but also when we talk about blood. So there are 4 types of blood. Really there are 8, but we're not there yet, okay? We're going to add the other piece in. But there's A, B, and O. And basically what it means is what antigen do you have on the outside of your red blood cells? Or what protein do you have on the outside of your red blood cells? So if you look at this picture here, the red circles are your red blood cells, and the little shapes on the outside represent your antigens, or the proteins on the outside. And if you're blood type A, you're going to have an A antigen. If I'm blood type B, you're going to have a B antigen. If you're blood type AB, you're going to have both A and B antigens. And if you're type O, you have no antigens, right? Oh, because it's a ghost. Oh, do you get what I'm getting at there, right? Oh, it's a ghost that's going to come in handy when we talk about donating and receiving blood. Anyway, okay. Also in your blood, in your plasma, you have these antibodies to fight off what you don't want. It's a very exclusive club up in your body, okay? If I'm type A, nobody but A can come in. And so what I have here is an anti-B antibody. So you can see the shape of my anti-B fits the shape of the B antigen. So if they come in contact with each other, what ends up happening is the antibody tries to attack the red blood cell and ultimately clots your blood, and that is not good. Okay, so they're protecting your body from what doesn't belong. Right? As long as you have it, it's all good. But when something foreign comes in, your body goes a little whack, and right, and that's all thanks to your antibodies. So that's a good thing. So same with blood type B. You can see, right, blood type B has anti-A. So B is anti-A because I don't want A up in here, right? And your antibodies will fit into that A antigen and react. Blood type B has no antibodies because A and B are present. So I'm not trying to fight anything off. Like, all are welcome. And type O is like, no, like VIP room. Nobody's allowed in. Nope, nobody. Okay. So if you're blood type A, you have an A antigen, and your antibodies are anti-B. If I am B, I have a B antigen, and my antibodies are anti-A. You got it. All right. All right. Blood type AB is antigen A and B, and antibody, I'm not trying to fight anything off, so nothing. And O is a ghost. Ooh, right? It has no antigens, and has all the antibodies because it does not want A, so it's anti-A. I'm writing with my mouse, so this probably looks a little funky. I'm anti-B. I don't want B. Alright. Good. Here's the chart I just wrote out for you, for your records. Okay. And that's not all, because you probably know if you're A positive, A negative, right? The positive and negative is something called the rhesus factor, or the Rh factor. And it refers to whether the presence or absence of the D antigen. So if you're Rh positive, right, it's present. And if it's Rh negative, it's absent. So it's either there or it's not there. So if you're A positive, you would have A antigens, right? So I have my A antigens there, along with D antigens. So I have both of them. But if I were A negative, I wouldn't have those D antigens. I'd only have my A antigens. Now, this slide might make sense to people who really get it, because I always get this question. It's not super important for you to know, but people get so curious about this. I just kind of wanted to throw this in there. That when you donated blood that's given to someone is separated into solids and the liquid. So really red blood cells and plasma. And so the plasma has all that other stuff, including antibodies. So when you receive blood, you're really only getting the solids, just the red blood cells, so you don't need to worry about other people's antibodies that would attack your body. So I just wanted to throw that in there. Like if you receive O blood, you're not getting those anti-A, anti-B antibodies, because O is the universal donor because it has no antigens. So if I'm A and I'm getting O, right, my body won't attack that red blood cell, but their antibodies are left out of my body, so that won't attack me, if that makes any sense. Okay, so donating and receiving blood. Who can receive what kind of blood? So going back to my rhesus factor, my Rh factor, if you're positive, that means you have the antigen, but you don't have any antibodies. So I can receive positive or negative. But if I'm negative, I can only receive negative because I'll have those anti-D antibodies, and if I receive positive, it'll attack it. We want a very peaceful transfer here. Okay, so A positive can receive A positive, A negative, O positive, O negative. A negative can receive A negative and O negative. So B positive, you can always get what you already have, right? So B positive, B negative, O positive, and O negative. Because remember, O is I'll stop doing that now. Just kidding. I don't promise anything. Okay. I can receive B negative. I can also receive O negative. Try and do AB positive on your own. What can AB positive do? I'll give you like a quick few seconds to try and think about it. Okay, is that enough time? If you're AB positive, you can receive AB positive, AB negative, and guess what? You can also receive, that's a positive, A positive, because you have A's already, right? A negative, B positive, B negative, O positive, O negative. You guessed it. This is the universal receiver. I'm a bad speller, so if I spell this wrong, forgive me. Okay. Universal receiver. You can get any kind of blood. AB negative, though, right, can get all that, but just not the positive. So AB negative, A negative, B negative, O negative. Look, I can't keep up with my own self. Okay. And finally, O positive can get O positive, but can only get O negative. Also, and O negative can just stay by itself. However, right, O negative is present in all groupings, right? O negative is there. That's why this is the universal donor, because there is 0 antigens on their red blood cells. Ooh, it's a ghost. I did it again. Okay. Crack myself up. Okay, here is the chart without my messy handwriting through a mouse. All right, so we're talking about this because of that blood typing that we did. So the wells, like you did in your lab there, right, on the virtual lab, your wells look like this. And so what I'm going to do is I'm going to put a drop of blood from each person, or from one person, in one tray, in all 3 wells. So I would put, right, a drop of blood here, a drop of blood here, and a drop of blood here, all from the same person. Now when I use anti-serum, that anti-serum acts like an antibody. And the antibody, if it's present, if an antigen is present, there will be a reaction. Serum. Okay, serum. I don't know if I spoke right. There's the bell. I'm going to keep going because I'm recording this. Alright, right? Is the same as antibodies, okay? And those antibodies would clump or react if an antigen is present. So if there's a reaction, I know that it's present. So let's say I test this person and I have a reaction in A and a reaction in RH. That means that A is present, so I'm A, and RH is present, so I'm positive. There's no B antigens present. I'm A positive. Let's say just B reacts. So B antigens are present, but A is not present, and RH is not present, so I would be B negative. What if all of them react? All of them. Oh my gosh. That means all antigens are present. So I have A, B, positive. And what if no reaction? Zero reaction. No antigens. I would be O negative. And that is how we build